Welcome back. In this clip, we are going to create an effect of a radial field. So let's discuss what exactly is a radial field. Well, radial field can execute the force in an omnidirectional way. It can create both the effects, like it can generate the force in an outward direction also, as well as the inward directions, depending upon the magnitude. With positive values, we have outward force. With negative value, we have inward force. All right. And you can also see we already have a scene prepared with the particles, and right now I'm using these flowers which are instanced with the particles. So this is kind of a customized geometry which is assigned to the particles. So how we have created this, we are going to discuss about the instancer node particularly in our upcoming module, so we don't need to worry about this. As if for now we just want to concentrate upon the radial field. So let's select the particles and go inside the FX menu. Over here we have the field solvers. Hit the option radial over here, and this is basically the radial field. So let me just reposition this and press the F to focus this field. Over here we have, all right. So now let's play the timeline and let's see how it actually affects the overall scene. So with this, you can see it is executing some forces, and as we can also see, if we press Ctrl A, we have the magnitude as well as the attenuations. Alright, so let's get rid of the attenuations for a moment, and let's also move inside another good attribute, that is the distance. Well, here it is already checked on by default, the use max distance. It simply means that right now we have a magnitude of 20 max distance. It means from the point of this field to a distance of 20 units, this field can execute its effect. After 20 units, it won't generate its own effect. Alright, so that means the ability or the power of this field is limited to 20 units, and 20 units simply means for 20 centimeters. So let's don't do this. Let's switch off this attribute, and let's increase the magnitude to somewhere around 15. And now if I play the timeline, you can see this field is wonderfully performing, and it is simply executing an outward force, which as a result of this, particles are moving further away from the point of this field. But this is something which is not like aesthetically powerful. So let's do one thing. Let's create some more aesthetic qualities inside this. Let's make this effect a little bit more gradual, or a little bit more in a fall off way, so that it could be noticeable to us. So we can use the volume shape as a sphere. All right, so we simply need to scale this and animate this, and the rest of the things will be handled by the radial field. So let's do one thing. Let's key the scale attributes of this field, and let's say we are at frame 100, and let's scale this to a little bigger amount. So we are at, let's say, approximately 10 units. That's fine, and put a key over here. So you can see now, if we play the timeline, how nicely this field is affecting the particles. Really very nice. Well, we can do some more things. Let's increase the values. Let's say we increase this to somewhere around 12.5 units. That's nice, and put a key over here. And let's also increase the magnitude to somewhere around 25. All right, and you can see we still have the use max distance disabled. That's really very important. And now if you play the timeline, you can see how nicely these particles are getting pushed outwards because of the positive values of the magnitude. So with the positive values, this field can generate an outward force. So it will create an omnidirectional force, but with the positive values of the magnitude, it will push the particles in the outward directions, all right, from the point of this field. That's very important. Now let's do one thing. Let's change the magnitude to the 25 to, let's say, -25, and you notice all these particles will get attracted to the center point of this field. And this is also something very, very nice. All right, so at the moment we still have the self collision enabled. So because of this, these particles are not overlapping with each other, or due to the self collision, they are detecting their presence and they are colliding with each other. All right, so that's just all about this radial field, and that was a quick look inside the radial field. Now let's move to the next clip where we talk about the uniform field.